Which graph matches the equation y equals -4 times the square of x minus 1 minus 2? Our textbook refers to this as the standard form for the equation of a parabola. Other sources refer to this as the vertex form for the equation of a parabola. Because the x part is being squared, notice the equation fits the form of y equals a times the square of x minus h plus k. When we have an equation in this form, the parabola has a vertical axis of symmetry, which means it opens up or down. If a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens down. In our case, notice a is equal to -4, and because a is less than 0, we know the parabola opens down and will look something like this. Not too helpful in this case because all the parabolas open down, but notice we do have a vertical axis of symmetry. The vertex is the point h comma k, and the equation of the axis of symmetry is x equals h. So now let's find the vertex from the equation. Again, the vertex is h comma k. Because we have the square of x minus 1, notice h equals 1. And because we have a minus 2 on the end here, k is -2. So now we know the parabola opens down and has a vertex of 1 comma -2. Let's see which of the parabolas that are given open down and have a vertex of 1, -2. Only 2 of the parabolas actually have a vertex of 1 comma -2. Both are in the second row. This parabola opens down and has a vertex of 1 comma -2, and so does the next graph. Now we need to determine which of these two graphs would match the equation. One way to do this would be to consider the absolute value of a. In our case, a is -4, and the absolute value of -4 is 4. If the absolute value of a is greater than 1, which is our case, the graph is vertically stretched from the basic graph when a equals 1. In this case, the graph appears more narrow. When the absolute value of a is between 0 and 1, the graph is vertically compressed and appears wider than the basic graph when a equals 1. And therefore, this graph here on the left is the correct graph. Another way to verify this, though, would be to find the y, or vertical intercept. So let's also do that. Recall to find the y-intercept, or vertical intercept, we set x equal to 0 and solve for y. So if we sub in 0 for x in the equation, we have y equals -4 times the square of 0 minus 1, or the square of -1 minus 2. Simplifying, the square of -1 is +1, and -4 times +1 is -4. -4 minus 2 is -6. The y-intercept is 0 comma -6, and notice only this graph here on the left has a vertical or y-intercept of 0 comma -6. The graph on the right has a different y-intercept. So now we know this is the correct graph for the given equation. Before we go, though, let's look at an animation using Desmos to see how the value of a affects the graph of the parabola. Notice I've entered y equals a times the square of x minus 1 minus 2, and below we have a slider for a, so we can change the value of a. Right now a is set at -4 to check our answer. Notice the vertex is 1 comma -2, and the y-intercept is 0 comma -6. We did select the correct graph. And now let's see how the graph changes as we change a from -4 to +4. Notice when a is negative, the parabola opens down, and as soon as a turns positive, the parabola opens up. I'm going to go ahead and set a equal to 1. Remember, when the absolute value of a is greater than 1, the graph is vertically stretched. So as I move a from 1 to 4, the graph is vertically stretched and becomes more narrow. Now let's go back to a equals 1. When the absolute value of a is between 0 and 1, the graph is vertically compressed and gets wider, which we see here. And of course, as soon as a turns negative, the parabola opens down. I hope you found this helpful.